Thank you everyone for joining. Today we're going to be talking about the EMP hardened solutions that we offer in conjunction with Sol-Ark inverters for their EMP proof models as well. So that being said, we're on the battery side. We're currently the only LFP batteries that can be EMP hardened, which is pretty cool, pretty unique solution. So it allows you to not have to use the old heavy AGMs that don't like being discharged or, stringing together a bunch of boat batteries. So it's a pretty cool solution today. But that being said, my name is Zach Reagan. I'm the regional sales manager for the Western Division. And also we have Ricardo Nava on the call as well. If you want to introduce yourself, Ricardo.
Of course, I'm Ricardo Nava. I'm technical sales manager for EndurEnergy. I'm a mechanical and electrical engineer. And we've been working on the EMP side for almost 2 years now. And as Zach mentioned, our battery is the only one in the market with the chemical composition that we have that can actually sustain an EMP discharge.
Cool. Alrighty. Yeah, and if you want to move on to the next one. Our agenda for the presentation, we'll go over a little bit about ourselves, about the company, about its history, some of the things we've done in the past, and some of the things we'll do in the future, our product portfolio, why EMP hardening is going to be an important solution for some, and then talk about the specific EMP products that are related to that, some install examples, and then a summary and Q&A at the end. So looking forward to that. So about EndurEnergy, our headquarters is actually in Silicon Valley, California. We have multiple warehouses around the country, but most of our personnel is going to be out of a city just north of Dallas called Allen, Texas. We are actually out of a neighboring building to Sol-Ark. So yeah, it definitely enables some advantages there, and especially with the EMP solutions. So that's kind of a quick location. And then our mission is to power the needs of our customers by delivering high quality and 100% reliable battery storage systems. Sorry, I'm getting just a tiny bit of lag, but it's coming through okay. So we've got a lot of key partnerships. We partner with different inverters. The main one right now is going to be Sol-Ark. We'll talk about more in the future potentially as things progress, but we've been extremely happy and blessed to be working with the Sol-Ark inverters. We've got a lot of different sister companies that are basically from investors that are also invested in them, and there's kind of a board of people that communicate a lot and basically just try and help each other. So it really helps you have some awesome teammates at a company level. And that's been critical in the past. And we definitely utilize that as much as we can. And that kind of ties into the backing from the industry leaders as well. They're tying in both financially as well as with their time and effort. There's a lot of successful people that have mutual interest in us succeeding and growing as a company. So there's some great backing there. And then, like I mentioned, being close to Sol-Ark, it helps a lot when people are buying inverters and batteries. So, we can kind of ship out on the same pallet, as we say. So, but on our side specifically, we do have a pretty high volume supply chain from our OEMs that we can deliver 5 megawatts on demand. That would obviously take, the drive and the pull to fire that up, but it's certainly doable. But yeah, we don't have issues with stocking like some other people. We just kind of order as needed and haven't had any problems. So we're very happy about that. And I think there's a lot of good foundational pieces set up so far. This is going to be a look at our batteries. The one we'll be talking most about today is the one you see on the left, which is the residential EMP battery. That's going to be you probably heard it called the 5100, very similar to that, but with the EMP protection. So that's going to be a capacity of 5.12 kilowatt hours per battery. You can stack up to 10 packs in a string. After that, you're going to need the BCU. So not a big deal. That's another product, very common for us to do that. And then you can have 8 strings per system. As you can see at the bottom, that is UL 9540, 9540A, CEC, and SGIP listed. Our newest battery that we've been pushing for a lot of non-EMP solutions so far is the 5K HL. The HL stands for high and low. The same exact battery you can hook up in parallel for low voltage, series for high voltage, configure it accordingly, and it's going to work for both solutions equally well. This becomes a huge advantage for distributors and installers that want to hold inventory, because if you want to buy 1,000 batteries at a time, but you don't know if you're going to be doing high or low voltage projects, if you had to distinguish between two different batteries, that makes your forecasting a little bit trickier. So this is awesome. You can buy a ton, set them up however you want, and you're good to go. So that's a single SKU product for both. This one also stacks up to 16 packs in a string versus the 10 for the 5100. And then again, you'll need BCU units after that. And then again, eight strings per system. This is UL 1973 listed. All of the other ones are pending, and hopefully that's extremely soon. I've heard from friends and colleagues in the industry, the battery testing right now seems to be kind of a bit backed up or slowed down for some reason, because I have heard this from multiple people now. So hoping that's extremely soon. There's no reason at all that this won't be passing all things 5100 did. So yeah, excited to see those come through. This utility battery over on the right, that one's not currently out. We have had some, excuse me, some prototypes and testing units that we've done. We've got the infrastructure to push it when needed. But right now, I guess this is a testament to the 5100. We've been creating and successfully delivering C&I solutions with the 5K HL. So while this utility battery would, have a place, we've definitely had our hands full just pushing the 5K HL, and it's been an absolute workhorse, and kind of, building on the legacy of the 5100 as well. So these utility batteries, I'm not going to get too much into. You can see some of the specs down here. It's going to be 14.336 kilowatt hours per stack. And then you can stack up to 5.2 megawatts. So these are some monsters that we'll have out at some point, but residential and C&I has definitely been focused this last year or two. So these battery units we've kind of become known for. You might recognize the racing stripe, as we say, but these cabinets are very very cool. They're I don't know if simple is the right word, but they're not overly glamorous where you're going to risk any reliability or integrity issues. They're very good outdoor rated enclosures, and they house our batteries. If this is our battery pack, they're going to house all of them vertically. So that makes the form factor pretty nice, especially if you want something like a garage. I'm in Texas. A lot of people have trucks. The garages are already not overly deep. So if you start stacking some of the other battery units out, they're going to come away from the wall, and they're going to start eating up your space pretty quick. So these are really nice because with all of these, again, they're outdoor rated, so you could put them outside as well. But even if you did want them in a garage and you just want that form factor, this BU15 here is a very common one. But starting from the left here, we've got 10 kilowatt hours ending over at 30. Basically, think of these as kind of two different models, and then they're stretched. So this BU10 is going to be two batteries on top of each other. The BU15 is going to be three batteries on top of each other. And then the BU20 is two deep. So it's a BU10 times two. BU30, as the name implies, it's a BU15 times two. So some of the best form factors that I think is out there right now, especially for people where space is a concern. We have our indoor units as well, the racking systems, which we'll get to, but those are going to stack the batteries, the way you'd lay them down here. So these are fantastic for a stacking factor. And again, the outdoor rating is keeping them important. They're not going to be something you'd buy and put someone else's battery in. They're something that you would buy usually just full of batteries. So if you wanted a BU30, it's already going to come with those 6 batteries. Not to say that you have to. These models without the batteries in them are going to be called E. So it would be an ESP E30 for Enclosure, and that's not going to have the batteries. So again, for distributors or installers that want to hold inventory, we've hopefully thought of everything there. So that's very helpful. Like I mentioned, this is our indoor solution. You can tell by the picture, you're looking at the face of the batteries on each of these, and it's basically a really cool, elegant, overbuilt server rack that looks great and does the job well. And it's still going to be very space efficient. But again, they're going to be laying down where it's not going to be that vertical form factor. Um, and again, these are also only indoor rated. So this isn't something you'd have outside. And especially with it holding a lot more batteries, um, it's something you would want it in some sort of building. Even if you wanted to have your battery storage offsite, it'd be something where you could put it in. I'll call it a shed, but a small building that is protected from the elements. Um, the names, they're not misleading because this holds 13. The top spot is technically allocated for a BCU, because if you were going to stack a whole bunch of these, you're going to need BCUs every few cabinets. So kind of an added bonus is, yeah, these make sense for 12 batteries and a BCU, which you wouldn't need on the 5K HLs. So the R12 actually holds 13 batteries and the R6 holds 7 batteries. So yeah, very cool form factor again, and they look great. This is something that we see a lot in people that have whole rooms dedicated to their ESSs, where they'll have the inverter right beside, 2 or 3 of these. And again, this is going to have a lot of power per square foot on the floor. So it's going to basically be a tiny bit bigger than one of our batteries, but just obviously stacked up. So these are really, really good solutions. Very affordable as well. You don't have to worry about fancy wall mounts or anything for, like the Teslas. The Teslas look great. Yeah, you can stack them, but again, you're going to be mounting everything to the wall. That weight adds up. Batteries are not light. Our battery packs are about 100 pounds each, roughly. And I've moved enough around to know that they're certainly movable, but I wouldn't hang too many of these on the wall. So again, we think that the floor stacking is kind of the way to go for a few different reasons. But yeah, so that is our indoor racking solution there. So on the EMP hardening, a few reasons, and we actually get asked this a lot of times. People say, "Why would I worry about that?" They assume that this only applies to nuclear war or something like that. Yes, this would help in the EMP generated from nuclear blasts, but again, and Sol-Ark actually does a great job covering this and kind of mentioning it as just an added level of safety. Is severe weather, all it takes is a lightning strike to get massive, voltage spikes, I guess. So if you have an EMP hardened system, you are much less likely to have any issues. And even solar flares, we could maybe call that a weather condition, but there are certain natural things that occur where EMP protection will help you. But again, there are other things. I'm not gonna fearmonger anyone too hard on here, but an EMP detonation, if it were to happen, is very devastating to everything electrical, including the grid. So for certain customers, it is nice that they have a literally bomb-proof solution. So yeah, it's very cool. But again, it's for people that just want that extra peace of mind for their family. Power is pretty critical these days. We're all watching this over Wi-Fi on our electronic devices. So while this may not be a critical thing, having something like communication or heat, depending on if you're in a cold climate or cooling in a hot climate, power is certainly critical in this day and age for sure. And then this is a look at kind of the star of the show today. So this, like I said, is our ESP 5100 battery, and then it's going to be with the EMP package there. This battery is very nice because it has an internal BMS, a battery management system, like you'd expect from any LFP batteries. This allows monitoring and protection. We have proprietary algorithms, and then the proprietary EMP portion of this is built in as well. So we'll cover some of the details of some other small pieces that you'd receive for the full kit, but the bulk of the technology is actually built into the battery. Speaking of monitoring, it is very important, I think, in this day and age, especially with with certain events that are going on, have gone on, and probably will continue to go on. All of our data is stored in AWS. Every single ounce of control, commissioning, support, everything is in the US stateside on the ground. We've had our team, while they're in China or something, try to get into these batteries. You're not going to get in. There's no data exchange with them. There's no offsite locations where it's like, oh, we actually need something in China for this. It is all stateside. That is a very large selling point for a lot of people, and it is a competitive advantage over some of the big names in the industry that you'd be surprised by on both the battery and inverter side. So that is certainly an important feature for a lot of people. We take it very seriously. This is military grade. The EMP testing, I believe the kind of easy round number is, just remember, whatever the EMP protection the military covers, it's about 3 times that. So yeah, kind of military grade times 3, but it is tested under the same procedures that military devices that are EMP hardened have to go through. So very cool. And then here we have the Sol-Ark lineup, which I'm sure everyone's pretty familiar with. Fun little tidbit. I actually used to work for Sol-Ark as their marketing manager, so I've got a lot of experience with the Sol-Arks. Still appreciate their continued work and their products very much. Very proud of having worked there. And that being said, I do have a lot of kind of additional insight that's a lot harder to stack up, and just experiences, being purely an outside observer. So I at least personally back these. I've seen their EMP hardened inverters. I've seen them be tested. I've seen what goes into them. They're beasts. So again, they're going to have proprietary EMP protection as well. They have 5 technologies built in to the inverter. Those are not something that the details are going to be shared about. As you can understand, that's kind of the secret sauce for these products. But I can assure you, as can they, that is a different unit. You're not gonna buy a normal, let's say, 15K and slap on some suppressors that are included and think that it's EMP proof, because that won't go well. But that being said, yeah, the EMP suppressors are also a critical part. So that's kind of your 6th element in this whole package. And these suppressors are going to be very similar, pretty much the same as the ones we use. So if you buy a full EMP kit that's batteries plus an inverter on a pallet, you're going to have all these suppressors. You're going to clamp them on a bunch of different wires. We actually have a video on YouTube where I covered that with Dylan Hillman from Sol-Ark. So yeah, it's very easy to set up. As far as if you're used to installing like a 15K and EndurEnergy batteries, the added steps to make an EMP proof system are a few minutes of your day, maybe an hour max. So it's not like you're having to relearn everything or do all these crazy extra steps or programming or anything like that. It's going to be a few kind of mechanical devices that are clamping on, and you're off and running. So yeah, very cool technologies, but all the important stuff's built in, and then you just got to do a little clipping and you are ready to go. And with that, I'm going to go ahead and hand this over to Ricardo.
Thank you for all the insights on our products. And yeah, so basically, as Zach mentioned, these kind of EMP hardened systems are going to have basically the same setup that you will have with a normal solar inverter and with a normal 5100 Endure battery, right? So the main difference would be the built-in technologies that we have inside the batteries and inside of the solar inverter. But regarding of installation and regarding commissioning side of these kind of systems, it's going to be pretty similar. The only thing that we will add to the commissioning will be where we're going to be installing the different suppressors that Zach mentioned before. So with the solar, you will receive a package of suppressors that you will be using to protect your photovoltaic panels. You will be using those to protect your loads. And with our batteries, you will be receiving the EMP suppressors to as an extra degree of protection for the power connections that we have going to the Sol-Ark and to the batteries, right? So this is like the overall kind of design of the EMP hardened system. Um, and I'm going to go through a few slides where we are going to speak really briefly on how you should do decommissioning, how you should do the uh, settings for the batteries inside the Sol-Ark. Obviously, this is going to be a really quick overall kind of view. We're not going to go too deep into the different configurations that we can have. As I mentioned, our battery can be stacked one battery up to 10 batteries without a VCU. And then if we use a VCU, we can go completely crazy and have 80 batteries in there. But we don't have enough time in this webinar to go through all of those different configurations. So I'm going to be focusing on one of our most popular products and one of our most popular configurations that we have right now, which it's going to be using a VG20, which will be the equivalent to use 4 of our batteries for these kind of systems, right? When you see the ESP5100, this is how it will look from the front. It's a pretty simple uh, design. We didn't want to go super over the top with confusing things. We have 3 main interfaces. The first one is going to be our deep switch interface. This interface is the one that will allow us to do different configurations. That's basically means that when we have a VCU or when we want to stack multiple batteries together, the deep switch is where all the magic works, and that's where you need to configure everything for you being able to use multiple batteries every single time. We have the communication in interface, which is going to be basically Ethernet ports that we are going to be using for the communication between the batteries and the inverter. And we also have the power cable interface that we have in there. So that's how the energy is going to get out of the battery and it's going to reach the inverter, and then it's going to reach all our different systems inside our houses so that we can sustain the energy, right? Our battery is a rack design. Usually when you go to the market and if you start looking at LFP batteries, you will find that people call these rack, a mounting rack, rack mounting, rack design, something like that. Basically, this will be able to fit any kind of rack that we have out there. Although, as Zach mentioned, the weight of the battery would actually make it difficult for this battery being used inside a normal server rack. That being said, there's a few companies that sell the actual supports for the batteries for these kind of weights to be supported by the racks on a normal server rack, but that usually is a little bit more expensive. Our racks are specially designed to sustain the weight of our batteries. Also, our PU units or our enclosures are specially designed to sustain different kinds of weather and also to sustain the weight that we have from these batteries. Right. So the first thing, and this is just like a zoom to the deep switches and to the Ethernet ports that we have in there. You're going to have 5 different deep switch or 5 different switches in there. Uh, 4 of them are going to be just normal on and off state switches. And you will have one, which is also considered a deep switch, but it's going to be a rotary switch, right? So the switch number one, it's going to be the switch that will define the type of communication that we will have with the battery and inverter. Okay, so in this case, we're going to be linking with Sol-Ark. So all the communication between the batteries and the Sol-Ark is going to be done using the CAN communication protocol. Therefore, SW1, which is going to be our switch one, needs to have the position 1 and 2 on. Position 3 and 4 it's going to be on the off setting. All right. All of these different settings are inside our installation manual. So if you guys have any doubts, you can reach us. You're going to have our emails at the end of the presentation. But also you can just go to our website, download our installation manual, and the installation manual is going to have all the different configurations for the deep switches, right? And SW4, and I'm going to skip SW2 and SW3. You will understand why I'm skipping those a little bit here, but I'm going to go with SW4 and SW5 because they're like the easiest way to, or the easiest deep switch to set up, right? SW4, you need to set that only the position 5 to the on position. The other switches need to be on the off state. And for SW5, you need to set up 4 in the on position, and the other positions are going to be off, right? So SW1, SW4, and SW5 are going to have the exact same configuration for all the batteries that you are going to be putting inside your system. But where the magic happens is going to be with SWT and SWT3, sorry, which it's going to change depending on the different configurations that you have, right? So what I mean by this is if you have just one battery, SW1, SW2 and SW3 are going to have a certain configuration. And if you have 2 batteries, SW2, SW3, it's going to change. If you have 4 batteries, they are going to change again, right? So as I mentioned, oh, I think this kind of shifted downwards. I don't know why, but this is going to be the deep switch configuration that we have for our batteries. In each one of the arrays for batteries, you are going to uh, determine one battery that's going to be the primary connection to the inverter, right? That primary battery is going to have those 2 switches, SW2 and SW3, set up as the image shows. SW2 is going to have the position 1 and position 3 on, and the selector switch is going to have the position 4 selected, right? So basically, when we are doing the configurations for the deep switches, the primary battery, it's always going to have the number of batteries that you will have in your array in SW3. Uh, then the first sub battery needs to have SW2 completely off. All the values inside SW2 needs to be on the off position, which is on the bottom side. And starting from sub 1, you will start counting towards the end. All right. What I mean by this is that SW3 is going to start in 1. Okay. Sub 1, SW2 completely off, SW3, select 1. Then you go to the sub battery 2. Again, SW2 is going to be completely off, and SW3, you need to select the number 2. When we reach the last battery that we're going to have in our battery array, that's where things get a little bit tricky, if you want to consider it that way, because in order to tell the configuration that that is going to be the last battery in our array, we need to activate the position number 1 in switch W2, and SW3 or the switch 3 is going to be selecting the number 2, right? These configurations are like super critical because usually when we are doing some kind of troubleshooting or with a lot of sometimes when you got some kind of communication faults, usually those can be fixed just by looking at the deep switch configuration and making sure that you have the proper setup. In our manual, we have all the configurations that you can have starting from 1 battery up to 10 batteries for the 5100. And for the 5K, which is our high and low voltage battery, you have the configuration starting from 1 battery up to 16 batteries. Once you finish setting up the deep switches in the batteries, you will need to connect your communication cables. Those communication cables are going to be included with our BU units, and it's actually pretty simple. you will receive a bunch of different cables. Those cables are going to be Ethernet cables, okay? So they're normal Ethernet cables that you will connect between the batteries. Something important is that if you see the different Ethernet connections that you have in the battery, you will have three different ports, right? You will have one port which is going to say inverter, and two ports that are going to say MS, okay? For the battery that you set up as primary, it's going to be the only one that will use the um, inverter port, right? You don't need to use inverter port for the other three batteries in your array. You are only going to use the inverter port for the primary battery that is going to be communicating to the inverter, right? You will connect the long Ethernet cable from that primary battery to the communication port or of the VMS port in the Sol-Ark, and you will connect between each one of the batteries one Ethernet cable, and for that you will be using the MS port that you have, right? It doesn't matter which MS port you use, as long as you are 100% sure that you're connecting between MS and MS port. It doesn't matter which MS port you use. The communication cables are super simple to connect, and once you set up everything, you can just pass to the power cables. I think I was missing a part. So the grounding cables. All our batteries will have a grounding point. It's really important for you to connect the grounding cable just as a safety measure in case anything will happen, that you can actually redirect all the surges that you can have to the ground. Each one of our batteries is going to have the grounding point on the lower left corner. You can undo the screw, and the grounding cables are going to come inside our battery units, and you will need to connect between each one of the batteries that we have that grounding cable. The grounding cables have an iLog connection or an iLog terminal that you can just screw into the connection point of the batteries. Once you are 100% sure you have all the grounding cables connected between the batteries, you then need to connect one of the batteries to the common ground that you have to the inverter also, right? This is a simple, really simple setup. Um, and even these grounding cables are super easy to make in-house. If you have like super basic knowledge on how to crimp things, you can actually manufacture your own grounding cables if needed. But yeah, grounding cables always for extra safety. And for the power cables, uh, with each one of our batteries and each one of our battery units, we will include the proper cable that you need to use to connect to the solar, right? Uh, as Zach mentioned, we have a video in YouTube that shows you how to set up the power cables and how to set up the suppressors that we're going to include with the batteries. Uh, you will need to connect. In this case, this is going to be low voltage because those are the EMP protector inverters that solar has. When you connect in parallel these batteries, you need to make sure that you are connecting the positives to the positive side and the negatives to the negative side. Okay, you will always have to connect two connections or two plugs to the battery. Okay, this means that you will need to connect a positive cable and a negative cable to each one of the batteries. Okay, these are a little bit different if you are speaking about series connection, but we are going to have a different webinar for that part when we talk about the 5 kHl. Uh, when you buy one of our PU20s, you will receive a 4 branch cable. This 4 branch cable already works as a DC combiner or as a bus bar, and you will only need to connect one of the heads or one of the branches to one of the batteries, right? You will receive one red branch cable that you will be using for the positive from the battery, and you will receive one black branch cable, which you will use for the negative of the battery, right? Also, with each one of our batteries, you will receive the suppressors, all right? As I already mentioned, these suppressors are just an added protection to the system, right? The main uh, use is uh, we own the patents and it's a proprietary part inside of our battery. Uh, but as an extra protection for the EMP, we have the suppressors, right? Uh, for each one of the batteries, you will receive two suppressors, and you need to connect those suppressors as close as you can to the actual connection point to the battery. Okay, so in there you have, I think you can see, I don't know if you can see it a little bit lag because I'm also seeing the transmission. I think it's a little bit lag. But you can see where you need to put the suppressors. You can also watch our YouTube video. It's super simple. The suppressors just clip on to the cable and they will stay there. And you just need to make sure that they are as close as possible to the connection points of the power cables, right? Once you connect your system, and once you have the batteries ready, and once you did all the commissioning from the solar side, and once you basically are turning up your system, you need to do or you need to set up your batteries, all right? How are you going to set up your batteries? It's super simple. You will see this screen in the Sol-Ark, right? In the LED screen, you will see um, this information menu where you will see how much energy you are receiving from your PVs, how much energy you are getting or you are sending to the grid, how much energy you are using for your loads, how much energy is going or you are taking from the batteries, right? Uh, in that screen, you need to click onto the system setup, which is going to be located on the upper right corner. Once you click in there, you will access to this menu, right? In this menu, you need to click on the battery setup, and the battery setup will send you to this screen in here, right? Something important that you need to take into consideration is going to be how many batteries you're installing. Okay, each one of our batteries can hold up to 60 amps of charge and discharge. That amperage is going to be stacking the more batteries you add to your battery array. Something that you need to configure in the battery setup, it's going to be the maximum charge amperage and the maximum charge discharge amperage that the solar needs to use for the batteries, right? So in this case, we have a setup for 4 ESP 5100s using a Sol-Ark 8K or a Sol-Ark 12K. If you multiply the 60 amps we can sustain on the battery times 4, that will give you 240 amps, right? The solars, at least the 8K and the 12K, have an amperage limit of 185 amps of charge and discharge for the battery bank, right? So you will need to make sure that the max amperage charge and discharge is set up to those values. And something important is that you need to activate use battery percentage charge, and you also need to activate the VMS lithium battery and make sure that the value on the right side of that selection box it's 00, and you also need to activate your battery. Okay, this will be the battery setup on the battery menu that you need to use for the solar 8K and 12K. And when you change to the 15K, the charge and discharge limits change, right? You can have up to 275 amps. So in this case, you can actually have the 240 amps that our batteries can sustain without having any issue. Therefore, you need to change the max charge and max discharge to 240 and activate also the selection boxes on the right side of use battery percentage charge, VMS lithium battery, and activate battery, right? Once you finish setting up that part, this is the only thing that is going to change between the 8K, 12K, and 15K. But once you set up the battery settings, you need to set up the charge settings for the batteries. So you will just go, let me see if I can have my pointer in here. We were in the battery menu. You just need to click on charge menu. And on the charge menu, you will need to make sure that you have the proper voltages for both absorption and equalization to guarantee that your system is going to be working perfectly. Those values are the ones that are shown on the screen. For float voltage, you will have 54.4 volts, and for absorption and equalization, you will have 55 volts, right? You just need to make sure that for either one of these inverters to set up the voltages as shown. And once you set up your voltages and once you set up your battery, as I showed before, then your battery is already configured and you can use your system as normally, okay? I didn't want to go really deep into how to do the commissioning on the Sol-Ark because think that they have a bunch of different trainings and a bunch of different webinars that you can use for that part. And they also have an amazing support team that can guide you step by step on the commissioning side of the Solar. You can also call us on our support line, and we can guide you step by step on the commissioning from the Solar and also for the indoor battery. And yeah, I didn't want to go a little bit over the time with the configuration settings for these kind of systems. So I just wanted to talk about the battery and the charge settings, which are like the critical parts when you're using our battery with their uh, EMP hardened inverters. Now we jump into Q&A. In this slide, you can see you have Zach's email, and you also have my email. You also have our support email. Okay, so you can send us an email with any questions or any doubts you have, or if you have any questions right now, we can answer them.
All right, I think we're probably good on questions. Yeah, we'll go ahead and wrap up here. Thanks everyone for joining. We will be doing a lot more webinars now. As you can see with the emails, if you have any questions, reach out to us via email. Our website is EndurEnergy.com. There's only one E in the middle. And then, yeah, we'll be happy to answer anything specifically for you. And then stay tuned to our LinkedIn and YouTube page for more content like this. But we will be pushing our webinar calendar quite a bit. So you can find that on our website as well. Register for whatever time fits you best. If it's a big project or you have a big team, we'll be happy to do a private training for you and the team and get you through commissioning and any other questions you might have. So yeah, thank you for joining, and we'll see you around.